Hello and welcome back to the course Private Pilot Maneuvers. Now we've talked about turns in the previous lesson, and today we are discussing a special case of turns, and that is steep turns. So everything we discussed in a turning lesson applies here. It's just that we're flying our turn with an increased bank angle. Now in normal conditions you probably fly turns with something between 15 and 30 degree bank. In the very standard case, you're flying at standard rate. So if the little airplane symbol on your turn coordinator matches the 2-minute marking, the little white marking, then you're actually doing a 2-minute turn, which means you're completing a full 360 in 2 minutes. But in a steep turn, we want more. Normally a steep turn is flown with 45 degrees bank or even a little bit more. Just keep in mind that the most normal basic trainer airplanes are limited to a maximum bank angle of 60 degrees. All right. So as with in any turn, first of all, make sure that the area where you intend to do your turn is clear, looking for traffic. So first of all, if you're inducing that bigger bank angle, as we've discussed in a previous lesson, you have to compensate that with back elevator pressure to increase that total, or the angle of attack and the total lift, therefore, so in order not to lose altitude. Now in a steep turn, you probably have to pull back quite a bit. Now what happens due to this increased angle of attack is also that you have increased your drag. So you probably need a little bit more power for the in the steep turn to keep your speed. So don't go into a steep turn too slow. Another reason for not going into a steep turn too slow is the increase of stall speed with the load factor. And load factor is depending on your bank angle. We'll talk a little bit more about that in the stalling lesson. We'll learn that the stall directly only depends on angle of attack. And this also in a given flight situation corresponds to a speed in which the airplane stalls. But all the given stall speeds in the handbook and also on the airspeed indicator, they're just for straight and level flight, but not for turns. So the stall speed actually increases by the square of the load factor. So for example, in 45 degree standard steep turn scenario, 45 degrees bank, your load factor is 1.4, and your stall speed is already increased by 20%. Now in a 60 degree bank turn, your load factor is already 2. So you're actually pulling 2 Gs. Actually your apparent weight becomes double. And this increases your stalling speed by 40%. Now this is considerable amount. Just imagine your normal straight and level stalling speed would be 50 knots. And with 60 degrees bank, this is 40% more. So actually your stall speed is now 70%. I'm sorry, of course, 70 knots. It's 20 knots higher. So really keep that in mind when pulling a turn with so much bank. All right, for performing the actual steep turn, it's important to find reference points on the horizon for your start and end point. I mean, normally you will fly those, or you will practice these steep turns by flying full 360s, or ending up on the same heading as you started the turn. So find a reference point on the horizon. That should be also your reference for ending the turn then. Remember, when you roll out of the turn, to do it early enough, so probably half the bank angle before, so roughly 20 to 22 or something degrees before you actually target heading start the rollout. Otherwise you will probably overshoot. Also keep in mind that you will probably have applied a lot of back pressure during the turn, maybe also elevator up trim, and you need to adjust this back pressure as you roll out, because as the bank angle decreases, you will need less of it. So keep that in mind, otherwise you will start climbing at the end of the turn. Also, there's the overbanking tendency that we've talked about in the turning lesson. So with a high bank, there's a tendency of the airplane to bank even more. So we might even need some opposite aileron during the turn to keep the bank at those 45 or whatever degrees. Now, if you're allowed to vary your bank angle, so for example, you should fly, or the target of the exercise is to fly a steep turn with a bank between 45 and 55 degrees, then of course adjusting the bank angle also helps in counteract any altitude deviations. So if the nose drops, you can reduce the bank angle a little bit, makes it easier to get the nose up again. That's especially important if you encounter a really nose down situation, because it's a very common error during steep turns, not pulling enough back pressure to keep your altitude, so that sometimes a steep descent starts. Now, if you're already in that situation, descending steeply nose down, it's important or advisable to first reduce the bank and then pull the nose up. It will make it easier to get the nose up, and it will also reduce the stress on the airplane. So what are the common errors during steep turns? Well, first of all, not clearing the area. So before you start a right turn, really look out the window, check for traffic. Ideally, maybe do some clearing turns, normal turns before, to really make sure nobody else is flying where you fly. Very common also is inadequate pitch control. So normally most students at first start to descend. So they lose altitude during a steep turn because of the amount of elevator pressure that's actually required to keep your altitude. And also common is not adjusting the pitch attitude at the end of the turn and then climbing away at the end. Also keep in mind to coordinate your turn, so also use rudder appropriately. Another common error is not using the rudder during the turn. Another common error is to fixate too much on the flight instruments and to miss the rollout. Either roll out too late, or you start stopping the turn too late. So keep in mind you have a high bank angle, so you need to lead your end of the turn by approximately half of the bank angle. All right. So that's the briefing about steep turns. Let's try it in the airplane. See you there.